7. Today we're going to look at factoring more polynomials, and specifically we're looking at factoring a couple of special types of polynomials. If you remember back to chapter 7.3 earlier on, we looked at multiplying special polynomials together through these different patterns. Well, now we're going to reverse that process and we are going to find the factors of those special products. So one of those special products is referred to as the difference of perfect squares. And the reason why is because the difference represents the subtraction sign. Perfect squares represents both terms are perfect squares. When you factor them, they factor down into conjugates. All right, the other two factors are trinomials, and they are called perfect square trinomials, and they fit into that pattern of a squared plus 2ab plus b squared. And when those get factored, what you'll find is that it is the square of the one factor a plus b. The other perfect square trinomial has the subtraction sign here, and it started off as a squared minus 2ab plus b squared, and when fully factored, that 2 gets factored down into a minus b squared. All right, so let's just take a look at a few examples here. These first two, you'll notice that there's just two terms, and this is kind of a dead giveaway. When there's two terms with a minus sign, you want to think about whether those two terms are both perfect squares. If they are both perfect squares, then what you have is this situation of the difference of perfect squares, and they will factor down into conjugates. So what are the conjugates that they factor down into? Well, it's that first term. You have to take the square root of that, so the square root of x squared would be x. And it's the second term that you have to take the square root of. Well, the square root of 25 is 5. So the conjugates that they factor down into are x minus 5 times x plus 5. And it doesn't matter which order you write those in. You could have written x plus 5 times x minus 5. All right, example 1b, again, you have two terms with a minus sign. So you're looking to see if both of those are perfect squares. 4z squared and 1 are both perfect squares. In other words, you can take the square root of them. They break down to 2z minus 1 times 2z plus 1. And those are the conjugates of that difference of perfect squares. All right, next in example 2, you'll notice that we don't have two terms. There's three terms here, and these do fit into the pattern of those perfect square trinomials. This first one here, if you notice, the first term is a perfect square, the last term is a perfect square, and that middle term is 2 times the product of the square root of that last one and the square root of the first one. However, you don't have to factor it based on that pattern. Just go back to where your information about when your leading coefficient is equal to 1. What you were doing is you were taking factors of 16 that combine to be positive 8. Well, the only two that are the same that are going to get you to positive 8 are 4 and 4. So this would break down to n plus 4 times n plus 4. Now typically when you have a factor that repeats itself, you would write that as n plus 4 in parentheses squared. So the factor of n squared plus 8n plus 16 factors down to n plus 4 squared. All right, likewise in example 2b, we do have the perfect square and a perfect square at the end here. And the middle term would be 2 times the product of 2x and 3. So this is a perfect square trinomial, and I know that this is going to factor down into 2x minus 3 times 2x minus 3. And again, the reason why I know that is because there's a minus sign here. And then take the square root of 9 to get the 3, and the square root of 4x squared to get the 2x. And so if I were to put these back together, I would end up with this perfect square trinomial of 4x squared minus 12x plus 9. And once again, when it's a repeated factor like this, we would write that as 2x minus 3 squared. All right, our last two examples for today. Again, we have three terms. It's a trinomial. It's a perfect square trinomial with a minus sign here. So I know that this is going to factor down into d minus 5 times d minus 5, or in other words, d minus 5 squared. Our last example here, d has two terms with a minus sign. All right, a minus sign that goes between them, and therefore this is going to be that difference of perfect squares. So these are going to factor down into conjugates. 9x squared minus 4 times 9x squared plus 4. Now, one more thing you got to be aware of, just because you factor that down doesn't mean you're necessarily done. What you might notice is that one of these factors is again two terms with a minus sign and both perfect squares. So you can factor this first one, 9x squared minus 4, down further. Because it's a difference of perfect squares, this would factor down into 3x minus 2 times 3x plus 2. And then finally, we'll carry down our other factor of 9x squared plus 4. And this illustrates a point here that you can factor the difference of perfect squares. However, you cannot factor further the sum of perfect squares. So keep in mind that this 9x squared plus 4 cannot be factored further over the real numbers. All right, so our final factorization for letter D is now 3x minus 2 times 3x plus 2 times 9x squared plus 4.